students, and welcome to my YouTube channel. Today, we are going to study the Black Scholes Merton model. So, this model is popularly known as BSOP, which stands for Black Scholes Option Pricing Model, which is popularly used in calculating a theoretical price of a European style option. And I wanted to stress this point that BSOP is only used to calculate the option value for an options which are European in nature, which means a European style option which can be only exercised at the expiry of the contract. So this model was developed by economists Fisher Black, Myron Scholes, and Robert Merton, and we will just look into it. That what is the formula? We will dissect the formulas, try and understand the mathematical modeling behind it, which is only required for the application side in terms of in finance, and also with the help of one of the example, we will try to solve one question. So here is a picture of those three financial economists who came up with this idea of a BSOP, and they are the one who introduced the mathematical framework of valuing the options. So in 1997, Black, Merton, and Scholes were awarded the Nobel Memorial Prize in Economic Science for coming up with this financial option valuation model. Unfortunately, Fisher Black was not alive at that time to receive the Nobel Memorial Prize. And Robert Merton has made a lot of a refinement to the model that the Black as well as Scholes have came up with. So the first one, Fisher Black, Myron Scholes, and Robert Merton, and the formula right next to the picture that you can see is the formula for BSOP for C and P, which means call option as well as an put option. Primarily for the purpose of understanding, I am sticking to the valuation of a call option in this video. So next, what we are going to do is to do a bit of a dissection of the formula of a BSOP. So you can see here that this is a call option formula. There are certain things which we are familiar with, and in order to make you understand, I prefer to rewrite this whole formula so that it is easy for me to explain this further. So the formula for a call or for valuing a call option is spot rate, and then I have something ND1, and then I have minus KERT, and then ND2. Now S stands for spot rate. So it depends upon whatsoever is the underlying security that is there in the option, what is the spot rate. So if it is a stock, so we will consider the stock price. Then K stands for a strike price, which is also known as exercise price in some of the books. Then we have R, which is a rate of return. And in order to follow the risk neutral valuation, we are assuming it as risk free rate of return. T stands for time. And then there is something which you call it as an E. Now, E is a constant basically that we are using. So, E is a constant that is usually used in exponential function, and for those equations which involve a kind of growth and decay. The value which you may find is 2.71828, right? And this is a function which is available if you're using your scientific calculator, so it is very easy to calculate. If not, then you can use this constant value, which is 2.71828. Okay, now we have written down all information except these two information, which stands for as ND1 and the second one as ND2. And that's very important to understand that what exactly is this ND1 and ND2 stands for. So let's understand that I'm writing this ND1 as a function, and what is this nx stands for? So basically what we are trying to say that this is a cumulative distribution function, right? So this is a cumulative distribution function. Now, what is this cumulative distribution function is all about? So, what is this? It is a cumulative distribution function for any standard normal distribution, right? And when we say standard normal distribution, what does we mean? That we are trying to calculate the probability that the random variable, whatsoever is the random variable, is less than or equal to x, right? Which means that if I'm calculating a value of this, the probability, and we know that probability will always be greater than 0, and this probability will always be lesser than 1. So basically what ND1 or NX is calculating, it is calculating the probability. Okay, now the next question is that probability of what? Now, if you remember the meaning of a call option, because it's important to just basically refresh your memories in terms of a call option. What is in call option? So, call option is basically a right to buy, right? So, if it is a right to buy, I should also be knowing that what is the fear of a buyer. So fear of a buyer will always be bullishness, right? So he fears that in future, if he wanted to buy, the prices will go up. So that's why he wanted to enter into a derivative instrument, right? This means that the payoff will come to him only when his fear is coming true. What does that mean? That if I wanted to compare SR with K, now SR is changing, it's fluctuating every day, but K is basically fixed by nature in terms of a derivatives, right? And say suppose his fear is coming true. So his fear is something like this, right? If its fear is coming true, he will have a payoff. This means that there will be a value in the options when this will come true. When SR will be greater than K, that will come true, right? Now, this is fixed, but this is random. This is changing variable. This is random variable, right? Now, when this is changing, I should also be knowing that what is the probability that the spot rate will be higher. And it is because of this reason we are doing this whole exercise of calculating this ND1 as well as an ND2. So we will look into it one by one, that what do ND1 calculate and what do ND2 calculate. So here you can see that the whole information just now what I have discussed, I have just pasted this information, that what is this basically normal distribution function. It is the probability with a mean of 0 and a standard deviation of 1 is always less than x. And what is my x? X could be my any random variable, right? Now, sometimes when you go through the book, you will come to know about this ND1 is basically delta. Okay. Now, what does this delta stands for? And it is the same delta which you might have done with me in class for Greeks, especially the financial derivatives students. So, what is this delta all about? So, delta is basically telling you the changes in the option value due to the changes in the spot rate. So, that is measured by a delta, right? Now, in order to understand this further, that what is this delta and what is this probability, it is important for you to understand what does this D1 stands for, right? So when we say that there is a way, how do we do a calculation of D1? So there is a formula for it. So what is that formula? It's the formula says ln spot rate divided by K. Let me put this in bracket, plus you will have to have a kind of a risk-free rate of return. So I have my R, so I may call that as an RF, plus variance divided by 2, and this whole is multiplied by T. Okay, so please, a word of caution here, don't put T as a power. T is not at all a power. T is the whole multiplication, and this whole is divided by standard deviation with respect to the time. So some kind of a new thing that came your way, right? So let's start with the denominator one first, that what does this stands for. So here, if you see what is this standard deviation, this is a standard deviation measured by sigma, right? And what happens in any of these standard deviation, that it always refers to an it refers to an annualized standard deviation of return. So refers to annualized standard deviation of returns, right? So, but when we are dealing in a time period, right? So, in our example, you may have a time period of 3 months, 6 months, 9 months. So, what happens is that when we say that a standard deviation refers to an annualized standard deviation of returns and a time period over which volatility is being scaled, could be days, could be months, right? In our example, it could be 3 months, it could be 6 months. Therefore, in context with respect to the time, it is expressed. This standard deviation is expressed with respect to the time, right? With respect to the time. So what does it do? It basically adjust volatility over time. So whenever we have if it is only for 1 year, okay, I can understand that it's all 12 months. But if it is for 3 months, so I have to adjust that volatility over time, and that is because of this reason. In denominator, you will find standard deviation with respect to the time. Okay, now moving on next, RF needs no explanation. Risk-free rate of return is there. Now this is a variance, which means again it's a square of your standard deviation. Here is spot rate divided by K multiplied by R. Right now, an important thing here is basically the standard deviation part of it, right? Now, in order to have just a bit more understanding, think about it. If I will take ln with spot rate with respect to k something, and let's assume it a value of 10 by 10. Now, what do I mean to say? I am basically saying that SR is equal to K. Now, what happens if SR is equal to K? We say that it is at the money. Okay. So, there are three things which you should know. If your SR is greater than K and your SR is lesser than K. Okay. And this is specifically for call. This is specifically, we are discussing it for call option. So when your SR is equal to K, it is at the money. When your SR is greater than K, that's where you will exercise, correct? If your spot rate is, if your fear is coming true, so that's where you will exercise. We call this in the money. Okay, in the money. This is always moneyness of an option, and this is out of money. So if I ask where will a person will exercise, a call option holder will exercise, you will say that he will exercise here, right? So let's assume that we are going to calculate D1 assuming the standard deviation as 0. So in order to calculate D1, D1 is equal to ln of spot rate divided by K plus RF plus variance divided by 2 multiplied by time, and this whole divided by standard deviation with respect to the time. Now, in order to calculate this, because we are not calculating any question, so what we are going to assume here is ln as 10 by 10, and then put a plus sign. RF we do not know, so we are not going to put that across, and our standard deviation was 0. So 2, there was nothing related with time, so here it is 0, the value is going to be 2, 0, right? Ideally, I should not show you this. When I say that standard deviation is 0, so everything will go 0 into this. Now, say after doing this, you got your final value D1 is equal to 0.00, right? Now, what is this 0.00? Now, for this distribution, I have to calculate, I have to check it out that what is the cumulative distribution. What is the cumulative distribution? And for that, I have to look for a standard normal distribution table. I have pasted somewhere this standard normal distribution table also in the same sheet. There is a way how do you search for a standard normal distribution. So say suppose if you are getting your D1 value as 0.00, so first and foremost your row so corresponding to the integer actually. So locate your row corresponding to the integer. Okay, so and here we are going to locate this, and then then we have to check for the column corresponding to the decimal place of D1. So in order to make you understand more, I will directly check for this value. So what I have to look for, I have to look for in a standard normal distribution table 0.0 for 0. Okay, what does that mean? If you come down, this is just a snapshot that I have pasted. So when you happen to see the standard normal distribution table, you will find the z value as a negative or a positive, because you may get a negative value also for d1 or d2. Here we, because we got a positive value, so we are checking this 0.0 for 0, right? 0.0 for 0, and we got this value 0.50. So what is our ND1 value? So ND1 value is equal to 0.50. Now please pay attention, because now I'm going to discuss that what does this stands for. Okay, so we are going to show this on a bell-shaped diagram, and I'm going to just cut this across. The volatility is 0. So 50% this side, another 50% this side. Why 50-50%? Because my normal distribution value, that is coming as 50%. Now what does that mean? And this value, people used to call this value as delta also, right? So let's see that what does it mean. So first and foremost, that what do delta measure? So it measures the sensitivity, that we all know. It measures sensitivity. Now, sensitivity of what? It measures the sensitivity, that how sensitive our option is in relation to the change in the spot rate of the underlying value. Okay. So it measures the sensitivity of option value with respect to changes in your with respect to changes in your underlying spot rate. So students, just now we have seen that what is a delta, and now with the help of some other assumption in terms of a delta, we will look into it, that what is the effect of change in standard deviation on your delta. Definitely, if we'll go with the theoretical aspect of it, the higher the volatility, the higher will be the delta. And therefore, this is what we are going to look into with the help of another example, where we are going to take the delta value as, say, more than 0. So let's assume the delta value for our calculation as 0.2. And again, as what we have seen in D1, we are going to utilize the same formula. Now, I'm not writing ln by 10 by 10, because this will always give you a value of a 0 only. However, just for your understanding again, I have written it down here. And this is my variance divided by 2. This whole will be divided by 0.02. Once you will simplify, you are going to get your answer as 0.1. What does it mean? It means that D1 stand as 0.1. I have to check it out, the ND1. And for this, I have to look into the value in a standard normal distribution table. And just now, I've already told you that how to look for this value. So I'll be looking for 0.1 for one value, which once you will find out in your standard normal distribution table, you will find it out a value something like this, or up till 2 digits, we can write this as 0.054. Now, what does that this means? It's very simple. It means that every dollar change in the stock price, up or down. Okay, so every dollar value change in your stock price, up and down, the value of the option price will also change by 0.45 cents up or down. Okay, and just for your understanding simplicity, I'm just going to write this down, this interpretation, that what is the 0.54 means. It means that every dollar change in stock price, change in, I will write it as, say, spot rate, up or down, the value of option will change. So the value of option will change by 0.45 cents up or down. That's what the interpretation is, right? Now let's assume that what happens if your sigma is again increased, right? So the only thing that you have to remember, sigma denotes the standard deviation, which denotes the volatility, and the more the volatility is in the underlying asset, the more valuable the option will be, right? Because it's because of this volatility you have entered into this contract. So, say suppose this time we are going to assume it your delta value, sorry, your standard deviation value as 3. And again, we will try and calculate D1. So, I'll just quickly write down directly that 3 divided by 2 and this whole divided by 3. If you will simplify this further, you will get a value of 1.5. Again, I have to look for ND1 value. And again, how do I do that? 1.5 for 0. This is what we will look into it. So I think I have somewhere pasted this table down. Yes, it's here. So I our value is 1.5. So 1.5 value is not here, but you may just quickly try and find that out. Let me paste this value from one of my file here. So I'll just quickly do this for you. So instead of this value, I will paste it here, this value. Okay, this will get deleted. Sorry for your time. Okay, so our ND1 was 1.5, and if you just get to see 1.5 for 0, you are going to get this value here. So this is the value in which we are interested. This means this is the probability 0.93319, or just for the simplicity, I can call this as 93%, right? And this is what I have mentioned here in terms of bell-shaped curve diagram as well. So what does this 93% means? It means that $1 change up or down is going to up and down in stock price, okay, or in SR, spot rate of whatsoever is your underlying. The value of your call option will change by 0.93 cents, right? So let me complete this. The value of option will also go up or down by 0.93 cents, right? So just in one liner, what do I want to see? That higher sigma makes your D1 go up, and higher the sigma, it will make your call option more valuable, right? So just in one liner, the more volatile the underlying asset is, the more valuable your option will be. Students, now we have understood the whole concept of ND1 and what is this ND2, which we will understand with the help of this question. So the purpose of this question is that how do we apply the BSOP calculation in a question, and then what is the interpretation part of it. So here we can see that this is a stock option whose spot rate is given as 30. This means this is a price which keeps on changing, and the exercise price, which is fixed in nature. We also call this as strike price 29, risk free is 5%, volatility, which is our standard deviation 25, and time to maturity is 4 months. We are supposed to calculate the option, which is a European call option, applying the BSOP formula. So let's get started. Let's list down some of the information, and don't forget that we have not yet discussed about the ND2, which we will be doing now. So I'm just listing down what all information which is available here, and these are the 5 information which I want. So spot rate is given as 30, strike price is given as 29. This is 5%. I can rewrite this as 0.05. Time frame is 4 months, and then the standard deviation, which is given as 25%, right? So this is 25%, so I can write down the 0.25, and 4 divided by 12 will likely give you 3, 3, 3, and 3. Okay, now we know that what is the formula of the call option for BSOP, so we will write down that formula. So call option is equal to spot rate ND1 minus K, and then we are trying to find out the present value of this K, and then I have ND2. Okay. Now, ND1, I understood that ND1 means that spot rate times delta. So, how much is the sensitivity that is there in the stock prices, which is affecting the valuation? And then K is raised to the power minus ERT is basically the present value of your strike price times ND2, which is again a probability. Now, the question of probability of what? Probability that option will be exercised. Okay, so ND2 basically calculate the probability that option will be exercised. Now you let me know that if it is a call option and there are two comparables, strike spot rate with respect to the strike price, when this is going to be exercised. We know whenever the my fear is coming true, only then it will be exercised, and the moment it will be exercised, this is also can be named as in the money, right? In terms of the moneyness. Okay, so we understood both what is ND1. ND1 stands for the delta, ND2 calculates the probability that option will be exercised. Now, having said that, we have to calculate the value of D1. So let me write down the formula of the D1 quickly. So it is ln, so spot rate divided by K, then plus 0. Let me just write down the formula first. So it is here as RF plus variance divided by 2 multiplied by time. This whole will be divided by standard deviation with respect to the time. This is the formula of ND1. Let's substitute this. So here we have 30 divided by 29 plus 0.05, which happens to be our risk-free rate of return. Then I have this standard deviation, but here we want variance, 2 square divided by 2. This whole will be multiplied by, again I repeat, multiplied by 4 by 12, right? And then here downside, I have my standard deviation, which is 0.25 with respect to 4 by 12. Now, once you will calculate, you're going to get a value of D1. So D1, I've already done the calculation, so I got a value as 4.225. I have to calculate ND1, which means that I have to calculate cumulative distribution function for this value 0.4225. How do we look for this? We will look for this value from the table. I've already pasted the table down, so we can see that 0.4 for 2. So 0.4 for 2, if I have to look for this value, 0.4 is this, and under 2 column is this. So our value which is going to come is 0.66276, right? So we already got the value of ND1. Now I have to calculate the value of ND2. For that, I have to calculate, I should know what does this D2 stands for. So D2 is basically standing for D1 minus standard deviation raised to the time with respect to the time. So we will quickly do the calculation part of it. 0.4225 minus 0.25, and then I have it as 4 by 12. Once you will calculate this value, you are going to get your answer close to the value which I am just now calculating, which is 0.2782. So once you have got this value, I have to calculate the value of ND2. So 0.247. So 0.247, which means this value. So 0.60642. Now I'm just simply going to substitute all of my information in my formula. C is equal to spot rate. Spot rate was 30 multiplied by ND1. If you remember what was our ND1, it is 66276. So I'm going to write down this as 0.66276, then minus sign in between, then my K, which is 29, and then I have to calculate the present value of this. So therefore I'm putting this as an exponential minus 0.05 multiplied by 4 by 12, right? So I believe you still remember what is this. We have already discussed. If not,
Please scroll back to the video and find out. And then multiplied by ND2, which is 0.60642. Once you will do the final some calculation of this, you're going to get your answer as 2.587. What is this? This is the option value. So this is the value of the option. And that's all about your Black Scholes option pricing model. Thank you.